Alright guys, today you're going to learn about the division properties of exponents. There are multiple power rules that you're going to learn. You're going to learn 4 of them. Now if you remember, we did learn 3 of them last time. One of them looked like this. When you multiply the bases, remember you have to add the exponents. So that gives you 4. 2 plus 2 is 4. Another one said that if you have a power to a power, and remember I like to say if they are stacked, then you multiply those exponents. And then the last one we talked about, if we have a power here, we have to distribute the power to both. So this would give you 125 or 5 cubed x to the third. So from there we're going to learn 4 more. We'll start out with the negative exponent rule. This says that if you have a negative exponent, it brings everything, including the base, to the bottom of a fraction. I'll give you some examples here. We have 4 to the negative 2. This will give you 1 over 4 squared, which will then become 1 over 16. The next one, x to the negative 3, will give you 1 over x to the third, and that can't be simplified. The last one, because the negative is already in the denominator, then we're going to, you could write it, this is what my class did yesterday, we wrote it as 1 over 1 over w to the 5th. And remember that if you divide by a fraction, you have to flip in times. So what this really does is that it gives you w to the 5th, or you can just take this original fraction and flip it upside down. So if that negative is already in the bottom, you have to move it to the top. If it's in the top, like it was in our first 2 examples, you need to move it to the bottom. Okay, your next property is called the zero exponent, and this we've learned before. This says anything to a 0 equals 1 as long as a does not equal 0. And we talked about it before. We said we started with something like 4 to the first, 4 to the second, 4 to the third, and we looked at what happened with each of these. 4 to the first is 4, 4 squared is 16, 4 to the third is 64, and we talked about what's happening as we go from this number to the next number, and you can see that we're multiplying by 4. So if I want to go the opposite direction, I'm going to divide by 4. So if I take 4 divided by 4, I get 1. And if we go backwards with our exponents, we're subtracting, so this would give you 4 to the 0. So this shows you why 4 to the 0 is 1. If we go back even one more and divide by 4, we take 1 divided by 4 is 1/4, and we go back with our exponents, and you get negative 1. And this shows you the last property, that if we have a negative exponent, it will become a fraction. So with all that, let's talk about these examples. 7 to the 0 is 1. X to the 0 is 1, and any complicated thing all to the 0 becomes 1. So here in example 1, you have 3 different examples. We have 6 to the negative 2, so we rewrite this as 1 over 6 squared. This becomes 1 over 36 in its simplified form. With b, I'm going to look at this. Anything to a 0 becomes 1, so it's like multiplying by 1, and we don't have to really worry about that. So I'll take this one. 5 to the negative 4 becomes 1 over 5 to the 4th. You can write that in a simplified form as 1 over 625. Okay, on c, again, anything to a 0 becomes 1. So 1 times 5 will still stay 5. This y to the negative 2 will move to the bottom, or the denominator of the fraction, and that becomes its simplified form. Your next property is known as the quotient of powers. This says that if the bases are the same and you're dividing, then we subtract the exponents, as long as a cannot be 0, because we cannot divide by 0. So if you notice here, we have 3 to the 4th over 3 squared. The bases are the same, so we're going to subtract the exponents, which gives you 3 squared, and 3 squared is 9. Another way to look at this I should say the long way to look at this would be to say that we have 4 3's in the numerator. We're dividing by 2 3's. If you see here, both of these divide out. We're left with 2 sets of 3's, and 3 times 3 gives us 9. Now, this isn't too long of a method if your exponents are 4 and 2, but if your exponents become really large, it's a lot easier to use the rule that we just subtract the exponents. Now, on the second one, our exponent is greater in the denominator. So because it's greater, we bring that x down and we subtract. When we bring the x down and the power down, we just don't see that first x. It becomes a 1, and we have x to the 7th minus 3, which then again is 1 over x to the 4th. So we could write these all out like we did on the last one. We would have 3 x's on the top, 7, I'll put it over here, and then we could go ahead and simplify those, an x for an x, and you see that we have 3, there's the 4th one, a 1 over x to the 4th, but this is a lot longer to write out than that. So we apply that rule to make things a lot less complicated. On example 2, we're going to simplify. The bases are the same here, so we're going to subtract those exponents, and it's greater on the top, so you'll have nothing left in the denominator. 3 minus 2 is 1, so we can either write x to the first, but because it's to the first, we don't need to write that power. You could put it over 1 to indicate that we started with the fraction, but again, that's not needed. On b, you can see that these have the same power, the a squareds do, so we're just going to divide those out. Then we notice that the power is greater in the denominator for the b's, so we're going to bring this down and subtract. Because we bring it down, we have to show that we have something in the numerator, so we put a 1, and you have b to the 5th minus the 3rd, so this becomes 5 minus 3, which is just 2, so it's you're left with 1 over b squared. Oops. On c, you have some coefficients. If you have coefficients, we're going to do what it asks us to do. You have 5 divided by 25. This will reduce to give you 1 over 5. So I'm going to do that right now. I'm going to look at my exponents for the x. You have an 8 and a negative 4. You're still going to subtract because we're dividing. The 8 is obviously greater, so I have 8 minus a negative 4. You can see when we have that double negative there, that we're actually going to end up adding those exponents. Then we'll look at the y's. The 5 is obviously greater in the denominator, so we're going to take 5 minus 3, and then all we do is simplify that. You get 1x to the 12th. You don't really need that x, or the 1, so I'm going to leave it off, and 5y squared, and at this point that is simplified. Okay, on our next slide we have power of a quotient. You've seen this before, we just didn't do it with a fraction. With the fraction, you're going to take this exponent and deliver it to both top and bottom. And again, as long as b does not equal 0, because you cannot have a 0 in the denominator. So with these, we're going to take this 4, distribute to both, so you get 2 to the 4th over 3 to the 4th. We can rewrite that. 2 to the 4th is 16, over 3 to the 4th is 81. As you look at this, what I like to tell you is if you look at the original bases, if they do not simplify, then our end value should not simplify either. But if you started with like 2 to the 4th over 8 to the 7th, the 2 and the 8 can simplify, so your end product answer, whatever it might be here, will simplify or it will reduce. So in our case, it will not reduce because the 2 and the 3 do not simplify in the first place. So I'll erase that. That's our final answer. On the next one, this 3, you're going to distribute to both. And remember, it's a power, so it stays a power. x to the third, y to the third, and the bases are not the same, so that one is completed. On your example 3, you're going to simplify these expressions. On the first one, I'm going to tell you, even though I have an exponent out here, I'm going to look and see if there's anything I can do to simplify within that fraction before I apply the exponent. So I notice that the 5 and the 6 will not reduce, so I'm going to leave it as 5 over 6. I can see that I have an a in the top and a in the bottom, and the bottom is greater than the top, so I'm going to go ahead and subtract those. That would become 4 minus a negative 2. Again, you can see where you have that double negative, you're going to have to add those values. Then if there is not an exponent on the b, remember that it's a 1. So we can see that the 1 is greater than the negative 2. So we're going to leave it on the top. 1 minus a negative 2. Again, you've got that double negative, so you'll add. Then I'm going to rewrite this as 5b to the third over 6a to the sixth, and this is all to the negative 3. Now, what this negative does right there is that it will flip your fraction. So it's going to take whatever you have on the bottom of the fraction, move it to the top, and whatever you have on the top, and move it to the bottom. So this 6, I'm going to start with that 6, it's going to move to the top, and then I'm also going to give it the power of 3. The a will move to the top, and it already has a power of 6, but it's to the third, so it now becomes the 18th. Remember that if you have those exponents stacked, you will multiply. We're going to move the 5 to the bottom, so it becomes 5 to the third, and we'll also move the b to the bottom because of that negative initially on the exponent. And we have a 3 to the third, so that becomes 9. And then the last thing you can do with this is simplify that 6 to the third. 6 to the third is 216, a to the 18th, and 5 to the third is 125, b to the 9th. Okay, with b, it's kind of the same idea. We have this negative 1, but I'm going to look inside my fraction and see if I can reduce it before I even apply that exponent. We have these coefficients. With the coefficients we're looking to reduce, and 7 divides into 28 4 times, so that reduces to 1/4. The w's are greater in the top of the fraction, so I take 2 minus a negative 4. If you want to put those parentheses, you can. And we have a double negative there, so that becomes plus. Our z's are also greater in the top of our fraction, so we have 5 minus 2, and this is all to the negative 1. We'll simplify that and write it as w to the 6th, z to the 3rd. You can leave that 1 there if you want, all over 4. And this is all to the negative 1. That negative 1 is going to flip your fraction, so the 4 will become the top, the w to the 6 will be on the bottom, as well as the z to the 3rd. And that is your end, or that is as simplified as that fraction will become. Alright, your assignment is the 6-2 division property of exponents. Good luck. I will ask that you guys work together in your groups on number 23. Read those directions very carefully. If you have a hard time understanding, I'll explain it when I come back. So good luck.